All right, so this is number 4 from chapter 9's end of the chapter problems. This is for the bonus points for exam 3. So what this problem is asking us is we want to find the mass. What mass of potassium bromide should be added to 120 milliliters of water to create a 1.8 molality solution? Now we know that the molecular weight of we're given the molecular weight of potassium bromide, and it's to be 119 grams per mole. So what is the equation of molality? That's the first thing we want to know, because if we don't know the equation, we obviously can't solve this problem. So molality, if we recall, molality, but I'll just spell it out. Molality designated by lowercase m, that's going to be equal to moles of solute divided by kilograms of solvent. Now, our solvent is always going to be the one of the two that's it's going to be the larger amount of that's in the solution between the solute and solvent. The solvent's always the larger amount, the larger quantity. So we know that we've got moles and we've got solute and solvent. So in this case, our solvent's obviously going to be the water. Generally, water is always your solvent in this case. And we've got 120 milliliters of it. So right now we see that we've got milliliters, but we need to rewrite this in terms of kilograms. So first and foremost, let's rewrite this in terms of kilograms. So in doing so, if I've got 120 milliliters of water, since we have water, we know that the density of water, we know that milliliters is equivalent to grams. So we can say that 1 gram is equal to 1 milliliter. And of course, now we can easily convert grams into kilograms by saying that 1 kilogram is equivalent to 1,000 grams. That should be 1,000. And whenever we calculate this, what we're going to get is we're going to get 0.120 kilograms of H2O. So now we've already found the bottom of this fraction. We have determined that the kilograms of solvent is going to be 0.120. So what about moles? Moles is a little different. All we're given right now is that we have 119 grams per mole, which is the molar mass. And we also know molality. So couldn't we also agree that molality is equal to, instead of writing moles of solute, couldn't I say that moles of solute is simply just the grams of solute divided by the molar mass? And then, of course, we can also say that this is all over the kilograms of solvent. This right here is essentially the same thing. What we're saying is this grams of solute divided by molar mass of solute is going to give us our moles of solute. We know this from, determining how to calculate moles. So now we're in a good place because we already know the molality that's given to us, the kilograms of solvent we found, and we also know the molar mass. So we've got 3 of the 4 pieces needed. So we just have this variable, I can call this X basically if we wanted it. And that's all we need to find. We just need to find how many grams of solute. And it's asking us what mass. Well, mass is measured in grams. So now we've got basically everything we need to solve this problem. So let's just go ahead and plug everything in. And then we're going to see what we're left with. So molality here, we found that, well, we didn't find it. It was given that it's 1.8 molalities. And then we don't know the grams of solute. So I'm just going to put grams of solute. And if you look down below, the molar mass, we were already given that. That's 119 grams per mole. And that's going to be divided by the kilograms of solvent, which is 0.120 kilograms of H2O. And let me make sure I rewrite the solute here in terms of potassium bromide. So then we have, so we're using the correct terminology. So this is what we've got. So now we just need to get rid of put stuff that we already know the values to on the left to solve for the unknown values on the right. Well, our unknown values just happens to be the grams of KBr. So now let me make some room here and erase this since we've already got these set up correctly. And if we pay attention to this, there's a few ways we can, if you think about, algebra, this is essentially right here. We've got an A over a B all over C. From college algebra, one of the rules in this case, A over B over C, we can rewrite that as A over B times C. You know, you can find this obviously by just looking at, you know, doing the keep change flip method. There's, you know, this is essentially one of the rules of college algebra. So essentially what I'm trying to say is I can take this 119 grams and multiply it by the 0.120 kilograms and get a value right there. So then I can easily convert it over to the 1.8 molality. So when I do that here, let's find out what I get. I'm going to get, essentially I'm going to get 1.8 moles is equal to grams of KBr divided by, now all of this is in the bottom, 119 grams per mole times 0.120 kilograms H2O. And again, this is KBr. Okay, now we're getting somewhere. Now I can just multiply these two together, and let me see what I get when I multiply this together. So I get 119 times 0.120. So essentially what I'm going to get here is 1.8 molality is equal to, again, grams of KBr. Now down below, I'm going to get 14.28. Okay, so 14.28 is going to be the value that's down below. Now what I can do is I can multiply this up on both sides here. Of course, it's going to cancel on the right. So I can multiply this 14.28 times 1.8, and that's going to be able to give me the value for grams of KBr. So let's do that. So I'm going to get 14.28 times 1.8 is going to equal grams of KBr, and or we can call this mass as well, which is what it's asking for. So when I take that times 1.8, the value that we found, we're going to get a final answer of 25.704 grams of potassium bromide. So basically, the final answer here, we're going to need 25.704 grams of potassium bromide that should be added to 120 milliliters of water to create a 1.8 molality solution. And that's basically it for this problem.